Hi, my name is Brajesh Chaudhary and watching the Quantum Guru. There is an important category of problem in collision, especially in nuclear physics, in which we are interested in knowing how much a colliding particle scatters as a result of collision, what can be the maximum angle of scattering. So in this video, we'll investigate that thing. I'll take a simple case, special case, in which a particle strikes a stationary particle obliquely. Collision would be elastic. So as a result of collision, we'll like to derive the angle of scattering of the striking particle in the ground frame and the C frame, and what can be the maximum value of the angle of scattering in the ground frame. So let's go ahead. So this is the picture of the problem. Here in this picture, in the ground frame, the two particles M1, M2 collide elastically and collision is oblique. M2 was initially at rest, is being struck by M1, which approaches M2 with velocity u. The line of motion of initial line of motion of M1 is drawn by this dotted line, and we can say this is say x-axis. As a consequence of collision, M1 gets scattered by angle theta. The angle of direction of motion of M1 with the original direction of motion is theta. After collision, M1 moves with velocity v1, and after collision, M2 moves with velocity v2. And this is the LOI of the collision. Will not require, but just mentioning. Line of impact is the line along which the particle initially at rest moves. The same picture, if we see from the C frame is also called zero momentum frame. Total momentum is zero, and in two particle collision, the particles moves always opposite to each other. So initial velocity of m1 in the C frame is u1c. Velocity of m1 is u1c, and initial velocity of m2 is u2c. And after collision, m1 deviates by angle phi in C frame, and after collision the velocity of m1 become v1c, and after collision the velocity of m2 become v2c. And we know that in C frame, in elastic collision, the speed of the colliding particles do not change. What changes is just their rotation. They only rotate. So m1 gets rotated by phi, and the speed of m1 remaining same. It means the v1c is nothing but u1c, and for that matter v2c is nothing but u2c. And how much they deviate, how much they scatter in the C frame, and that can virtually take any value, because this phi is determined by the line of impact, the relative masses, and the relative velocity. But whether they can deviate the same amount, what value they will deviate in the ground frame, that is the main question. So once again, let me reiterate, this theta is the angle of scattering of m1 in the ground frame, and phi is the angle of scattering in the C frame. And I wish to find a relationship between theta and phi. So let's look the ground frame first. Ground frame, we are looking, the velocity of center mass is suppose vc. So this vc would be nothing but how much? m1u upon m1 plus m2. And this vc will remain constant, because in the absence of any external force, the velocity of center mass remain constant. And you can see that this direction of vc is along the initial direction of motion of m1, that is the x-axis that I told, this dotted line x-axis, or you can say in the direction of u. So after collision, even before collision also, the velocity of m1 in the C frame, initial velocity of m1 in the C frame is u1c, and there is a direct formula for that thing, but we can find it immediately here from the relative motion result. u1c is the u1 minus uc, and uc is vc because velocity of center mass is same. So if we put this value of vc, we will get m2u upon m1 plus m2, and this u1c is actually v1c. So we can write this v1c is equal to, because u1c is equal to v1c. So v1c is equal to m2u upon m1 plus m2. And the two velocities of m1, one in ground frame, which is v1 vector, and other in the c frame, v2 vector after collision, are connected by this relation. v1 vector is equal to v1c vector plus vc vector. vc vector is along this x-axis. v1 vector is at an angle theta with the x-axis, and v1c vector is at an angle phi with the x-axis. And now I will connect them graphically in the next page. Let's go to next page. So this is how I am connecting these three vectors. This was vc vector, which was along this x-axis, and this is a v1c, which was along which is at an angle phi from the x-axis, and v1 vector is at an angle theta from the x-axis. So relation was v1 vector is equal to v1c plus vc. And I just written the values of v1c. This v1c I had written m2u upon m1 plus m2, and vc is equal to m1u upon m1 plus m2. So this enables me to find a relationship between theta and phi immediately. So from this diagram, we can see that this tan theta is equal to this perpendicular upon base. And this perpendicular, this is v1c. So this perpendicular is a v1 sine phi. And this whole base is vc plus this part is a v1c cos phi. So we can write tan theta is equal to v1c sine phi upon vc plus v1c cos phi. Put the value of v1c and vc in this equation, and you can see that in both v1c and vc, u upon m1 plus m2 is common. So if I put it here, so I am going to get m2 sine phi upon m1 plus m2 cos phi. And this result will become even simpler, look very better if I divide this numerator and denominator by m2. So then finally my expression will become tan theta will become sine phi divided by m1 by m2 plus cos phi. This is the relationship between the angle of scattering of the same particle m1 in the ground frame and in the C frame. In the ground frame, angle of scattering is theta, and in the C frame, angle of scattering is phi. I told before that phi can take any value, but whether theta can also take any value. So let's investigate. And that will depend actually on the relationship between the m1 and m2, whether m1 is greater than m2 or whether m2 is greater than m1. So let me take a first case in which m1 is less than m2, and also we'll interested in knowing what is the maximum angle of scattering that can have in the ground frame. So case 1 that I'm going to take, m1 less than m2 mean the striking particle has a mass smaller than that of the particle which was initially at rest. And with written, I'm writing again that vc is equal to m1u upon m1 plus m2, and v1c is equal to m2u upon m1 plus m2. So from these two, we can infer that M1 less than M2. So we can say that VC is less than V1C. So we will once again make that graphical diagram. So in that diagram, like here in this diagram, you can see that this VC vector was along the x-axis and V1C vector as angle phi from the x-axis and V1 at angle theta. In the C frame, the speed of the colliding particle do not change. So V1C will be a fix in magnitude for the same initial boundary condition. Boundary condition remaining the same, V1C will remaining same. But what can change? What can change? Phi can change. Mean the angle of, if the line of impact is different, phi will be different. So I can show V1C vector like this. This is actually not V1C. This is not VC. This is V1C. This is V1C vector making angle theta with the x-axis, phi with the x-axis, and it can take any possible value of phi. So I can show the various possibilities of V1C on a circle. On a circle whose center is at the tail of this V1C vector, and the head would be on this. Or the center is on the tail is on the center, and head is at any point of the periphery. So if I keep on moving this V1C vector, the magnitude will not change, only the orientation will change, and because phi can take any value. And then there is a VC vector. VC vector was along the x-axis, so VC vector would be here, but because the magnitude of VC is less than V1C, so VC vector will lie totally within this circle like this, and add VC and V1C to get V1. So now as this V1C takes various orientation, like if the V1C is along this direction, so V1 vector will be along this direction. So that means theta is 0. So this is a proper head-on collision. And then if the V1C is like this, so V1 vector would be like this. If the V1C is like this, V1 would be like this. If V1C is like this, V1 would be like that, and so on. So you can see that here in the ground frame, this theta can take any value. So the maximum angle of scattering in the G frame is 180. So theta can take any value. So what do we mean by any value? Mean from 0 to 180. 180 is the maximum scattering, i.e. theta can be between 0 to 180. Now whether the same happens in the case of the M1 less than M2, M1 greater than M2, let's see in the next case. So this case is, in this case, the colliding particle has a mass greater than that of M1 has a greater mass than M2. And see, once again, VC is M1U upon M1 plus M2, V1C is M2U upon M1 plus M2. If M1 is greater than M2, so now VC will be greater than V1C. So VC is greater than V1C. And if VC is greater than V1C in the same diagram, like if the VC is greater than V1C, so this is circle of radius V1C. This was V1C. So this VC vector head would be at the tail of V1C and the tail would be outside the circle. So that would be represented like this. So that would be represented by this. So now what can be the maximum value of theta that we have to see? So let's see few orientations in the next diagram. This is VC. V1C vector would be such that its tail is at the center of the circle and head could be at any point on the circle. And this diagram, the head of V1 is at the head of V1C and the tail of V1 is at the tail of VC. So V1 vector tail is at the tail of VC and the head is at the periphery. So various possibilities of V1 vector. this possibility here. This is a v1 vector. So this angle of scattering is how much? This theta is 0. The next theta increases a little bit. Then theta further increases. Theta further increases. And then now theta decreases. So we started from 0 scattering, a bit more scattering, more scattering, more scattering. Now the scattering decreases. So what we can infer? What is the maximum value of scattering? At which position the angle of scattering is maximum? Isn't it clearly the scattering is maximum when this vector is tangent to the circle? Because otherwise, this, if it is not tangent, so in all the orientation would be within that line. So the angle of scattering would be maximum when the v1 vector is tangent to the circle, mean like this. This is a v1 vector. This is v1c vector. If this is a tangent, so this angle will be 90 degree. And this is vc vector. And this is the theta max. So you can also say that the maximum angle of scattering would be when the velocities of the colliding particle after collision have a angle 90 degree in the C frame and the ground frame. So then it becomes a straightforward matter to write this theta max. So from this diagram, I can write sine theta max. Sine theta max is how much? The V1C upon VC. And V1C is M2U upon M1 plus M2. VC is the M1U upon M1 plus M2. So if the put value of V1C and VC, I will get, this was, sorry, M2 and this is M1. So then we'll have theta max is equal to sine inverse of M2 by M1. And that is the maximum angle of scattering that a colliding particle can take in elastic oblique collision in ground frame. So thank you for watching this video. Stay tuned for such videos, especially for IIT-JEE Advanced and Olympiad. So please do like and share this video. Thank you.